Good morning. Good morning, everyone. We should have Sage shortly. He's just finishing up the core stand-up call.
Good morning, everyone.
Good morning, Sage.
This is the last time we're going to do this on Wednesday. Next week it's going to be same time, Thursday. Unless anyone has any last-minute earnest objections.
All right. So we'll send out an email, and next week we will move over to same time, but on Thursday. All right, Sage, do you want to go through pull requests?
Yeah, let's see. This is the final list. Am I looking at the wrong pad? It shows PRs from January 18th.
January 18th. That sounds
right.
right.
Oh, no. Yeah, all right. That's better. That's fine. All right, let's see. There's a PGT log from Move Semantics for Kifu. I haven't looked at that yet. On the Blue Store front, we have a couple of them. The first and probably the most important is the one from Igor, which refactors their blob reuse stuff for small writes, makes it a bit more robust, and also fixes an issue with the previous version that got merged that was just creating too many blobs and in a bad way. So that's merged this morning. He has another pull request that fixes up the parameter tuning, makes some atomics, and adds hard disk SSD variants for max blob size. That one I still need to review. There's another one for me that does the same thing with deferred batch ops. Mark is looking at performance on NVMe because there was a bit of a regression after the throttling PR, which had something that changed the deferred batch op size. So we're hoping that's the case, but we'll see. Even with that, though, on small writes, the latency is higher and IOPS is lower for Blue Store than File Store. So we definitely need to figure out what's going on there. The code path is just a lot longer in this case. Things are looking good on hard disks, though. So there's that. Let's see. There is another one that's from Radoslav that changes blob refs into blobs and changes a bunch of types around. There's like 5 different things in that pull request that probably need to get tested separately and reviewed and tested carefully. So that's still a work in progress, but it's pretty promising. A couple ones merged. Radislav's D-table small optimization that his profiling turned up, that one merged. The throttling model one merged. Basically, that means there's now a single throttle in BlueStore. So you don't have to, it used to be throttling based on the number of ops in flight and the number of bytes in flight. Now it's just one metric, and it sort of does a kludgy conversion between the two, which should be good enough. And then now it's one knob that the auto tuning throttle stuff that Eric's working on will eventually be able to adjust. So that's in place. The next pull request, 14211, is the one that's actually going to make use of that. So I think the next step there is Mark needs to test it and see how it does. It's basically trying to adjust the throttles automatically based on a target latency. And so we need to make sure that works and how it performs. So we'll see. There's one that makes a tweak in file store to change the order of completions. That one makes me pretty nervous. I have to take a look at that. There's a related pull request somewhere in here in the pile that does something similar on BlueStore where it just combines the callbacks. Because in BlueStore's case, all the callbacks are called all at the same time. Everything is sort of is readable and writable stuff is the same. So we can probably, that one I think probably makes more sense, and I'm more interested in making the BlueStore stuff simpler and cleaner since that's what we're going to aim for going forward anyway. But we'll see. BlueStore is actually a little bit different in that everything's actually readable as soon as you submit the transaction. You don't even have to wait for it to commit. So it's possible that we don't even want the unreadable callback at all in the BlueStore case. So I might have to change that around. We'll see. Anyway, let's see what else. There is a bunch of other ones here. What's interesting? None of these are really new. Yeah, just all this other stuff that's been around here for a while. So,
Sage, what's the BlueFS write cache one? Igor was seeing test failures a while back. Is that still kind of a problem?
He was seeing test failures. Yeah, I haven't tried running it through the QA suite. So it used to have a bunch of other stuff mixed into that branch. That all got merged separately. So now that branch just has the write cache. So I could try it again. Yeah, I guess I should do that. I'll rebase that and just run it through the QA suite and see if I see any problems.
Okay. And how about the separating KV sync thread into 2 parts?
That one I think kind of dropped the priority a bit, but I think we might as well bump it up because it's pretty clear that it's going to be better than what we have. Not by a lot. It's probably going to be a small improvement, but I think it's the right direction, so we might as well merge it now, and that'll unblock some other stuff. So I'll put that back up on top of my BlueStore to-do list.
Cool.
I'll try to do that today. That and the BlueFS write cache. I think that's the next 2 things. Because then I can go back and resurrect the BlueStore run to completion patch, which has a bunch of good stuff in it, but needs to go on top of the finalizer thing. There are a couple other things in flight. One is that it occurs to me that we should probably make BlueFS take its chunk of space out of the middle of a hard disk. If we have a single device and we're sharing it, we should give BlueStore the middle of the device because that's going to minimize the arm movement. on hard disks. Obviously, it won't matter on SSDs, but on a hard disk, it should help marginally. I also need to make sure that fscheck memory usage is okay. I did some preliminary stuff that improved it, but I think there's still memory usage coming from somewhere that isn't accounted for, so I need to run it through massive, and that's going to take probably days on a full disk with all the data, so we should start that.
On the ARM movement, did you get a chance to talk to the guys at like Western Digital or whoever?
Yep, and the comment was something like, that should probably help. That sounds like a good idea.
Okay.
So it's like, okay, yeah. Yep. Yeah, the drives are being pretty clever, but it's still less distance to go, so it's sort of, it should still help.
Okay. It'll make the initial writes slower, so we'll just have to be mindful of that.
Yeah. Well, I mean, we could make it so that we also write data in the middle of the platter at the same time too, and then spread to the outside. But that's probably not really a good idea because everything else is going to slow down as the disk fills up anyway. So it's just going to increase the performance disparity between early and old. But I guess we should probably just try moving it somewhere else and then just see how much an early performance varies anyway, because that'll probably tell us if it's even worth doing in the first place. So yeah, it'll be interesting either way. It's a pretty easy change. It's a pretty easy thing to test out. So, okay. So I guess that first set of pull requests, the ones that are sort of in flight right now, are changing the way that BlueStore is handling the deferred writes. And the main change there is there's one more pull request here that's actually not on the list. Or maybe I don't have a PR open for it. I think I don't have a PR open for it, but it's the branch that you were testing that rewrites the deferred writes into explicit batches. And the reason it does that is twofold. One, so that when you have a deferred write twice on a block and it sort of throws away the old deferred write and the new one takes over, it does that tracking up front, which means that when we actually do the flush and actually send them all to the disk, it can do them in order sequentially, and it can coalesce contiguous IOs at the same time, which is easier on the block layer. They are ascending instead of descending order like they were previously, and basically matters for sequential writes. So these sequential deferred writes all get coalesced in memory and then sent down as one IO, which makes a difference. So that is, I think, ready for a run through QA, but it looks pretty good on the performance tests on hard disks. That's making a difference. There are still a few more things to do with that code that we can do there, but what we have now is pretty good, I think.
Maybe to comment on that specifically for Nick's benefit, probably the branch that you were testing, if you actually look with a block trace at the sequential writes, they're basically descending order. So it's kind of like you'll skip forward and then you'll start writing backwards, and then you'll skip forward and then you'll start writing backwards. So unfortunately, Nick, I don't know what your results look like, but that might explain it if they're bad.
Yeah, I was gonna say it looks like it's better than what it was, but it seems to be like coalescing it in the disk cache or something, because I'm sort of seeing an improvement, but the disk has got like a average wait time of 2 milliseconds. That's roughly what I'm seeing as the latency of the average IO coming out of VO. So yeah, I mean, I'd be happy to just test what these changes have done. I've also managed to kill everything using that deferred writes. Everything, literally every single ISD started asserting until I set the deferred size to 0 and restarted, and then they all recovered. I can send you the assert trace.
That'd be helpful. That's on master.
Okay. So I think I just pulled it from download Ceph Luminous, Debian Luminous. There doesn't seem to be a testing thing on download.ceph.com anymore.
Okay. Because if there's a Luminous branch that's being built, it's super old.
I'm sorry, you broke up there.
If you're pulling from the builder for the Luminous branch, that's probably really old.
Oh, okay.
I don't think that's been updated in a while. Whenever the last dev release was, I think that was a couple weeks ago. Not sure.
24th of March. It's got a date on it. Is there a master package anymore somewhere that I can?
Yeah, there should be. There should be one for master.
On download.ceph.com.
You can go to Shaman. That's probably a better place to go.
On sorry, where?
To Shaman. I'll send you the URL. I'll put it in the chat.
Right.
This is a new builder thing. Yeah, download.ceph.com is old and probably going. Oh no, sorry.
Right, okay.
No, you're right. No, so download.ceph.com is the actual releases, and so the Luminous one you're seeing there is the dev release that we're cutting every month or something like that. So that's pretty stale. But the Shaman builds are coming straight out of Git.
Okay, great.
Okay. Yes.
Nick, did you have any other things with the testing you did? Is there anything else we can talk about with it?
Not massively. I mean, it looks like whatever it was doing before, where it was the whole I/O was waiting on the disk to write. It's not doing that anymore, but it does. It's like if whatever delay there is in doing these curless writes at the disk layer, it's still sort of waiting on that. So if the average disk I/O is 2 milliseconds, that's roughly what I'm seeing at the Ceph side as well.
You're doing like a queued up to one?
Yeah.
Set of writes? And how many IOPS are you seeing?
About 500.
About 500. Oh, this is with the journal, SSD journal.
Yeah. So this is a 7.2K disk with an SSD which has got the Wellen DB on.
Got it. Okay. Well,
yeah.
See what I see in that case.
Nick, it'd probably be worth trying the whip deferred rewrite branch, and then playing around with the number of batch stops.
Mm-hmm.
If I bump that really high, it's still not as fast as file store, but it's definitely higher than kind of stock BlueStore.
Okay. Oh, the other thing, that batch stops, I did try bumping it up. So I think I bumped it up to 128, and everything just froze. Theo just wouldn't run. It just sat there on sort of 0 IOs. So I don't know if that's something odd as well. But
Try the rewrite branch and see if that works.
Yes.
There was at least one bug that we uncovered where it was just Sage fixed it. It was using the wrong lock.
Yeah. So in my tests, I see around 650 apps in this case with the journal on the SSD and the hard disk. The IO is going to the hard disk. What were you seeing on file store in this case, Nick?
So on my test box, I was getting I think about 700 or 800 on my tuned hardware, which I sent you that presentation for last week. I can get about 1600.
1600 with queued
These
up
are-
1 sequential.
Yeah.
Okay.
So on Inserta for queued up 1 sequential 4K writes, it's almost 2300 for file store, and about 922 for this is for throttle model, booster with the throttle model.
Yeah.
I probably have more updated ones since then, but that was what I was seeing at that point.
Okay. Yeah, on my test box, if I put it just straight on the NVMe, then I get like 770 or something. So I think this is just a slow code path. I think it's not specific to the hard disk part. It's the right path overall. Oh, you know what? I'm not doing the thing. -O pre-extend.
Oh, you're not doing pre-extend?
Not in my lab. I was before, just not in that one.
Okay. On NVMe, depending on throttle model, I was seeing about 1400 to 1600.
Yeah, no, I get 800.
What are you testing right now, Sage? What branch?
This is the Blue Store deferred rewrite.
Okay.
With RVD bench, queued up 1 sequential.
Okay. Interesting that's slower than mine. Oh, no.
Let's
This
see
is
if
interesting.
Rados bench is different.
Mark, was that when you were getting 2300? Was that to 3 times replicable?
No, that was 1x replication on a single OSD.
Okay, right. So my 1600 was for a 3 times replica.
Okay.
Oh wow. Okay.
How many nodes?
That would have been across about 5, I think, with 12 disks in each.
So, okay, that's why.
So I think probably a reasonable large chunk of that would have been network latency as well.
Yeah. This is local, so it's not going out over the network at all.
All right. So I think next step there is we need to do a better profile and see where the time is being spent. Maybe I'll do that today.
Yeah. Sage, do you want me to do that as well, or do you want to compare notes? It's fairly easy.
Sure. There's the other question we wanted to answer first. I forget what it was. We talked about it in stand up.
Yes. It was to look at whether on NVMe whether or not the batched ops
batch size. That's right. Yeah.
Batch size. Yeah. Yep. Yeah.
I've just in my GV search.
Sorry, say that again, Nick.
I've just emailed you the cert from the deferred write.
Okay. Perfect. Thanks. Resource temporarily. Oh, okay. All right. What else?
I wanted to bring up wall clock profiling. It's a good time for that. Basically, I want to reach out to the group here because I found out every 6 months or a year or so I come back to this, but the the only easy way I found to do wall clock profiling is to basically do poor man's profiling where you're calling GDB over and over again, and it's a pain in the butt. I was wondering if anyone here knows of any other tools that consistently work well for doing this. If not, I'm probably going to go and try to resurrect some ancient projects I've seen to actually use like GDB's Python interface so that you can go and get stack traces and collect them without having to like continually recall GDB over and over again. But if anyone has better suggestions, I'd be very happy to hear it. And that's pretty much what I was afraid of. Yep.
Wait a minute. So, yeah. I mean, you're saying the best way that you can profile things is with GDB?
Wall
For wall
clock.
clock. Yeah.
So what I'm interested in is basically, if you take a bunch of samples over time, where do you see yourself spending time in the code? What kind of locks are you waiting on, and just that kind of thing, as opposed to what you see from like push output. So this is kind of known as poor man's profiling, where you're just grabbing stack traces from GDB, and there's even just kind of a standard script that people have written to do this, and it's ugly and terrible. A slightly better way might actually be to use the Python interface to GDB to never exit GDB. Instead, you're just asking it to get stack traces then. And there was a project to do that like 5 years ago that doesn't appear to work very well. So I may try to just do that myself and see if it works. There's also an OCaml thing that I tried that, I don't know, it sort of works, but it doesn't actually seem to capture very useful information. So, yeah. This is... go ahead.
So the problem is that you don't really care about the CPU consumption. You're caring about the where, like when the IO is in progress, where is the, what is it doing?
Yeah. We want to see time spent waiting for locks, for example.
Yep. And so there's actually another thing out there that apparently does this, but it can't use dwarf symbols. So you have to compile with like the frame pointers. Basically, you have to no emit frame pointers on 64-bit, which I don't want to deal with. So yeah.
Guys,
yes.
Hello. One maybe one possibility. If I recall correctly, strace has ability to show you the time spent in syscalls. If you want to debug, if you want to profile something very, very roughly, maybe this will be a way to go. But still, it's not perfect.
Yeah, I'm not sure that'll capture the mutex weights either, because it's the weird.
Only in mutexes, I would say that only in situation when it comes to call futex syscall. In case of mutex contention, otherwise it's simply at operational atomic on nowadays P3 implementations.
It might be possible. Oh, go ahead, Sage.
I was going to say the other thing is that the mutex class that some of the code uses, the old mutex class, has instrumentation in it so that it actually will add a perf counter with wait times and average wait times. So that might be worth taking a look at. Sure.
Yeah, I mean that's the other route here, right? Is to actually instrument the code itself.
But that's not a very satisfying solution. Anyway,
one other thing that could maybe be done is to actually write something around libunwind itself, right? We could actually write our own little thing that grabs stack traces fast rather than the full GDB infrastructure. But yeah, it's a project.
Yep.
Yeah.
Okay. Any other subjects?
Well, regarding the lib unwind, I had one problem with this. If you happen to try to unwind with inside a signal handler, then it sometimes crashes, just tries to decode wrong frame and breaks. But just side note.
Yay.
Okay. All right. Okay. Anything else we should cover? All right. I think we're good for this week then. Next week, Thursday.
That's right.
Tell your friends. All right. Thanks, everyone.
Yep. Have a good week, guys.
Thanks. Same for you. See you on
Thanks.
Thursday.
Mark, you want to send an email?
Yeah, I will.
Okay.
Okay, guys.